Hi everyone, my name is Patrick Akil, and for today's episode, we cover the software engineering identity crisis. Especially with AI nowadays, I have a question for you. Are we becoming worse engineers overall with AI, or are we becoming better engineers? That's the topic of today's discussion, and joining me today, I have two people, both returning guests and friends of the show, Borislav Nikolov and Mirica. It was a blast having them on again, and I'm sure you'll love this one. So enjoy! I'm wondering, because I have a few friends that are more in the startup phase, and they love it for vibe coding. But to get to that point, before they love it, it was a bit of an identity crisis, because people try it out, they're like kind of resisting this change where you generate code that is actually quite good, and you can still change it, and it might fulfill your use case, to a point where they generate a lot of code. And especially in the startup phase, I still haven't seen bigger organizations with a lot of existing code be effective with it. But when you're starting from scratch, I can see how generating a lot of code to kind of fulfill whatever use case you have can be very beneficial. I wonder if people are going to go through this more so identity crisis, because engineering is changing. However you want to look at it, there is something new in there. And companies are also looking at that and being like, okay, do we still need this engineering capacity or not? So the world is changing, and I wonder what you think with regards to this identity crisis.
The identity crisis is for sure coming.
Yeah, right?
So yeah, for sure, because people are experimenting with it, as you said, for new projects and vibe coding and starting small. This is quite successful.
Yeah.
Sometimes it depends a lot on the field and domain, right? If we're talking about solutions that are more generic, CRUD applications, of course, and things that are more on the beaten path. Yeah, the coding, the copilots and so on, they can definitely handle those things. And so you're going to see teams that put a lot of put that to a lot of heavy use. And then those code bases will evolve into a structure that is kind of compatible with what has been done before with that copilot or coding assistant. And they're going to have a lot of success with it, I think. If we're looking at larger pre-existing code bases, they have their own idiosyncrasies, and they are not usually compatible with what the coding assistant will kind of expect, in a sense. So the coding assistant, because it is the average developer, in a sense, the average Stack Overflow developer, in fact, it has some built-in assumptions, in a sense. So, of course, your own corporate code base might not be compatible with those assumptions. So your engineers that have now a subscription and they are trying to use this coding assistant will discover that it's spewing up rubbish code that, even though the code might compile and it might even solve the problem, it's completely incompatible in a form, in style, in expectations regarding all sorts of things down to security, compliance, etc., with a pre-existing code base. So then that will introduce friction. I think there needs to be another couple of advancements, some serious advancements in terms of establishing a context and letting the agent understand its environment better for it to be useful in these situations. If you're a startup or a one-person startup, then I think you definitely should give it a go. It will give you a lot of boost of productivity and so on. And it's good to get into the habit of using it all the time, because you will have this extra degree of freedom, this extra resource that you can use for whatever, not only for, hey, can you write this function for me, or can you write this library code for me, or can you integrate this library code for me? But you can ask it all sorts of things about the domain that you're solving problems in. So it can actually replace a little bit of your business colleagues, your product manager, your data scientist, etc. It can give you some insights that you can use. And as an engineer, getting used to using that loop to improve your work, I think that's super productive. Now, when we're talking about like established code bases, I don't think that's gonna work that easily, right?
Interesting.
And then there's the question of, to go back a bit to the other conversation, there's a question of, we are now writing in human-oriented programming languages. So maybe there is a future in which vibe coding becomes the compiler step, not the editor step. Now we're in the editor IDE step of the of the human to computer, let's say, journey, right? So there's that feedback loop. Human puts in code into the IDE, then it passes on to compiler, processor, etc. Then comes back the output, you evaluate that output, and then you evaluate your code, compare it for correctness, and then you restart that loop again, and you then iterate and improve your code. But this, when you bring in the agent into this, then the agent must understand your human intent and the human-oriented programming language. That could be Java, C, Python, Perl.
Just to add to the human, I think that's so. The human abstractions and indirections, everything we do is because of the way we think and our limitations. So the way we manage complexity is very much expressed into this, like, okay, let's abstract. Where do we abstract? What's the point of abstractions?
Yeah.
The reason that why don't we code in microcode? M1 has like 600 registers. Why can't we just why do we need branch predictors? Why can't we tell which branch it's going to take? So we are incredibly limited in thinking in this incredible amount of interactions between pieces of the machine, of the computer, right? So we force at the moment, that's why we have all these languages and libraries and abstractions. To draw a pixel on a screen is like ridiculously complicated. It's like tens of millions of lines of code.
It depends on the machine, though. Not on ESP32.
Well, the ESP32...
it depends on the machine. So we have different levels of masochism.
I was just going to say the example of the ESP32. The ESP32 actually has some small standard library in diode-ROM. Okay, so it's baked into the CPU itself. And you actually, so the complexity, we even try in hardware itself, we have like help to actually control, and the way we control GPU controllers and the amount of registers and the register, all this is actually expressed in the wires. Yeah. And so even there, it's like it's not draw pixel on screen.
So you want to go even further. You want the GPT to output Verilog.
For example, that's an example.
Send directly to the foundry, and you get an ASIC.
For example,
that's exactly what you want.
That's like the absolutely. I don't want that. I'm saying from there, from the wires until to the abstract class, blah blah. Right? Yeah. Between those two things, and like draw pixel on the screen driver of like let's say you want to draw pixel from the JVM. Now from the JVM into the pixel, there is like I don't know how many million. Easily 20 million lines of code.
Easily.
Maybe
you need to go to the OS. You need to go to
it's great. Right?
Yeah.
So now we have all this like tower of abstractions. Yeah. Just because we're human. Because we're human and we're limited, and we try to actually make the more people share. There might be people that are incredibly gifted, like they can see through all this and they can actually code the microcode, and they absolutely exist. But I can't do it. No. So we have built this infrastructure of dependencies and like in an attempt to actually build more complicated things on top of the other things, because it's just not possible for us. It's not possible for us to program a DNA computer. Yeah, right? We just can't do it. We need like higher level abstractions in order to actually. It's the same way when you play a game of chess, you can't see the end of it. Right? Some people are better than others, but so.
But do you think we'll get to that point?
No, I don't think. My point is,
how far will we get?
At the moment,
how far should we push to get to?
But so there's two. One is like, should we even try to get that way? Because then it's like completely ininterpretable. And the second one is, what does it mean for the developers right now that are actually writing this code with a language model using human language? So because it's the same as the first thing, these tokens again are like human. Like when somebody writes a method that says, this is a simpler version of the. Let's say the John Carmack's fast invert square root function, the famous one. So there's like this number there, and then there is a comment there. It just says what the fuck on the comment. Right? That's what he wrote. You can see it on GitHub. So when he wrote, like when you ask a language model, it's going to output the same function. Right? So when it says what the F word, I don't know what you can say on YouTube, but what does it even mean? What does it mean? It's up to the reader of the code to decide what it means. Yeah. It's like nonsense. It's not nonsense. It's just,
No, it's not true. No. It's a necessity for that code to work.
No, it's a comment.
That is the
I see. Yeah. But my point is, then what is the point of naming? Right? So all these are made for humans by humans. When the thing writes something, it's like almost like imagine you're reading AI generated book.
Yeah.
What is the point? Why don't you get the prompt for the book? What's the point of you reading the book? You should just give me the prompt. I will write my own book.
Yeah.
So it's a little bit like that with the language model generated code. It's not, why would you read it? You see? Unless you want to evaluate it in your head, which makes you the computer. So why you see, you read this code, you run it in your head because the symbols are meaningless. You just ask, is that actually going to work or not? Why? And when you say like, oh, this is a simpler version of this, like simpler for who? You see?
Yeah.
So the identity crisis thing, which is what does it mean for me to code, is one thing, because the language model absolutely violates your, like especially Copilot. You write something and then all of a sudden a bunch of code spits out. And then you're like, wait, what? I was thinking something and now I have to read and pretend to be a computer for the thing that you wrote.
I'm thinking, finally, tab.
Yeah, that's fine. But before you press tab, you have to
interpret.
The thing is,
it's funny you think that I think
wait.
about something before pressing tab. That's really fun. No, it appears
listen,
I press tab.
The
and
thing
then
is,
I do run.
When there's latency, okay?
Yeah.
And you press tab and nothing outputs. I had this moment like a week ago.
Yeah, it's so frustrating.
And then I was like, wait, I don't know what I'm supposed to write now. I'm coding for 25 years, okay? I'm coding for 20, and all of a sudden I'm like, wait, what am I doing here? You know? And that's when I took a week off. And for 1 week I've been coding just in Emacs and then nothing on the terminal. And I don't have it anymore.
You went back to the old school days.
I went back to those school days. But I still use AI, but I use it I give it like 300-page documentation. I say like, make me a driver that uses this and this and this, just an API driver for the thing that I'm making. And then it just makes it. And I read the driver once and I embed it. But it's very different than it interrupting my thoughts. Because then I start depending on it for my thoughts.
But that's not a GPT issue. That's a tool issue, right?
Yes.
That's an interface.
Yeah, it's a way
issue.
we use it. Yes,
Yeah.
yes. I don't think it should be used while you're thinking, because it just stops you from thinking.
Yeah, but my question is more down the line of, would you rather continue down this path where you have Copilot give you code and you do tab, or would you rather replace that Carmack function with a prompt? Let's say we make a completely new syntax where we say, here is a function that does inverse square root really fast. And that's it.
Yeah.
And then we have all of these prompts structured in a sane way, in a way that we could reason about them from a human. You still need to have a human way of reasoning about what you're asking the computer to do, because otherwise you could not make an application, you could not make a business with just one prompt, make me rich. Then the prompt would be make me rich. But that's a recipe for the paperclip machine. And then you put this into GPT, and out comes bytecode that you just write on. You just send it to the x86 architecture.
So can we get there? Because the reason why it's really good at certain languages is because there's so much content of those languages out there. We don't have the same for bytecode, I would say.
This is really an assumption. This is really an assumption. So I think we're trying, but the thing is, we have taken a different branch. So we are in the branch where we are using these models to generate human-oriented content, tokens that we read, they make us happy, they give us information, etc., or they make us sad, etc. And out of this, we took this branch already because OpenAI thought that this is the most productive, economically productive branch.
I mean, humans are the audience, so from that perspective, it makes sense.
Yes, but we've done lots of things purely for machines. Like we have ASML here in the country doing things specifically to make machines better. So it's not a matter of we generally value things oriented to humans more. No, it's not because of that. It's just because this particular agent, this particular group of people have brought to market a product that works in a particular way and thus biased all of the research into that direction, because that's now the new gold rush. Okay. Now, on this gold rush path, we have generally society is scared of the gold rush, legitimately so. So now we're looking at how to guard against some of the pitfalls of going down that road. And this comes with, for example, interpretability or predictability or alignment. Okay, these things we don't need to compile code. Right? They are not necessary. Give me a sec. So not to the same degree, because code is verifiable. You can have C code gen where you can say, I give you a prompt. I know that the prompt is connected to some C code. So I know that the inputs and outputs of this function in C are correct. And my prompt, I think, describes the behavior of this function. I feed this into the training step, and I let the machine generate its own bytecode, direct bytecode that it can feed to the CPU, and it can validate that the bytecode that it generated validates the test that I gave it. And we can actually code gen this to extreme amounts. So we can create a training machine to train a new model that is not a model geared towards outputting human tokens, but it's geared towards a human input prompt and machine output. And then you align that with structure. So you say, well, now I'm going to give you bigger and bigger programs or applications or units, right? And they are going to be structured. The prompts are going to be structured in them in a particular way. And it should start generating, just runnable code. And you don't have to have the same things that you have for humans, because a machine is a much more strict system. So if this AI compiler fails, the functions are not going to output what you expected them. It's going to crash. So it's much easier for you to identify that something's gone wrong. Now, of course, if you tell it to create a banking application, that AI should be aligned not to facilitate fraud. So that is a problem. Okay, but that's a problem that any AI has. In any case, in the compiled code generating AI, these things again are machine testable. So even if you completely generate bytecode, that bytecode can still be analyzed and tested for all sorts of things. Like we do security testing for compiled code, complete black box testing. We put it in a disassembler. And then we look at the assembly code. And the disassembly language will still be available as long as we don't push it down the stack even further to what I was joking about earlier, which is, well, we could have the machine generate Verilog machine definition code. And then that machine definition code becomes transistors. And those transistors we truly do not understand. Then we go into simulations and it becomes much, much, much more complicated. But we already cannot do that because the costs of developing such systems are astronomical. So really the question then becomes, should I use a Copilot that generates Python code? Or should we invest in creating code compiling AIs where I speak English to it or Romanian, and it outputs direct bytecode. And maybe as an optional, I write a small test Python or C code class, and I validate its output. And then I put that in the loop, and it can just try again until it passes all the tests.
Keep in mind that there is no this, because we are so bad at managing complexity, we have not even understood programming, okay, as human species. So the computers even with the cloud and the most complicated applications that we have today are nothing compared to biological computers, for example. There are some lizards, when you cut their elbows, like you cut a piece here and then you turn it around, it's going to go through 2 elbows. So the complexity of biological systems is so beyond this emergent. It's so beyond what we can do. So I think it's a mistake. Like all the tech we have today I think it's just nonsense. It's like nothing. Besides the things that help you to like pick up potatoes from the farm, everything else is, I don't know. It's fine. Maybe banking. Like, I'm not trying to say, I'm just saying in terms of complexity. Okay. And usefulness to human species.
Okay.
So,
do you mean it's extremely simple?
No. I mean, yes. I mean, it's incredibly simple. Even with the abstraction towers that we've built, it's simple.
But it's extremely useful.
Yes. But what I'm saying is, if we want to go to the next level, we need a way to look into complexity. We can't deal with this complexity. We just can't. Regardless of the amounts of abstractions that we built. First of all, you know, because you can ask, why do we build computers with addressable memory? There is no reason for that. And because we could build sequential memory and all programming could still work. We are the way we are. People have been using addressable systems since Gilgamesh, like 4,000 years ago in Sumer, where they catalog kings, and this king was from this year to this year, and then they put it. They know how many years each king ruled, which year they can look up a king by a year and a year by a king. So this is just how we are. We put things in boxes with labels, and then we can find them.
Yeah,
and that's how we compute in our head. That's why we program the way we program, and that's why it's actually so hard for people to do functional programming, because it's just different. And it's not that it's weak, it's just different for the average person. Of course, there are some people that get it and they go that way. So everything that we have is in order to manage this complexity, and we're still not there. Right? So language models, I should stop saying language models. I think these massive neural networks can allow us to look into complexity with a human interface, a real human interface. So in order for us to build even systems like, fusion systems, or like something that is very, very complicated, very emergent, things very chaotic, we just can't deal with it. We can't model it properly. We can't react to it fast enough. We can't predict the things that are going to happen. Like even super simple, like 3-body pendulum thing, you look at it and you're like, what? You don't know how to manage that. So to make a program that manages it is even harder. And to make a program that manages like 10 billion of those, it's even harder. So we need help. Okay, in order for us to get to the next level of technology, we need help. Yeah. We need a looking glass into complexity that we can interface with. So that, I think, these massive computers, that's what they are, these differentiable computers, they can help us to do that. And we are completely misusing them now by making them like write me a LinkedIn post stuff. And just, it's like, it's insane. It's insane how powerful this technology is and how we are using it just wrong. We're using it to tell us what to do, like make me more productive. What is the point of being productive? What does it mean? The reason why people want efficiency and productivity is because they want to live 2 lives. Okay, they want to live more than 1 life in 1 lifetime. What is the point of being productive? You can just chill on the beach. Why do you want to be productive?
I mean, productivity gives you a lot of other things, right? I agree with you that
2
you
lives in 1 life.
As much as possible, basically.
So the idea is, if you're infinitely productive, you live infinitely many lives.
Yeah.
But imagine you live forever.
That would be a problem.
It's just the whole thing is very different.
Yeah.
So
that's why I want to be more productive, because my life is finite.
I know.
Yeah.
So that's what I mean. But imagine we make you immortal.
That would be a problem for the planet. We already have too many people.
That's fine. But then we go to the other planets. It's okay. We spread the problem.
We could decide to stop here and make ourselves immortal and stop having children, right? So it wouldn't be. I mean, it's still a problem for the planet.
Yeah.
But I mean, there are solutions to that. The bigger problem is that your own life would cease any meaning.
Exactly. Yeah. You would do everything you want, and then you would still have your life.
Yeah.
But
why?
Yeah.
Then
I don't think it's. There's nothing good coming out to go that way.
Yeah, there's nothing good.
Let's go back.
Let's go back.
My point is, we need to manage, in order for us to truly understand complexity, we're limited. We're too limited. We need a looking glass into it.
But is this iteration, is that what you're describing? Because this iteration is very much tailored towards humans, right?
Yes, but because that's what we can do.
Yeah.
But we can use it to build the next iteration.
Yeah.
Can we?
Yes.
Because this predictive model that you said, this neural network, is very much based on the content that is out there, right? That's what it's trained on.
No, wait. To predict the next state, you need to understand everything. It's like nothing is outside of context. There is no such thing as it. Like there is, when you interact with somebody, in order for you to guess what they're going to do, you have to understand the whole world. You have to have a world model.
Yeah.
You have to understand physics. You have to understand what they're going to do in order to have a theory of mind. Like if the model has a theory of mind of humans, it can emulate humans basically. So it's not just, it learns what it is to be a human. You know how you test theory of mind, the Sally test?
No.
So this is very simple. If we put your keys here on the table and there's like a box here, you go out and then I take your keys and put them in a box. Okay, and then I leave. I know that you're going to look in the box.
Yeah.
Because I can pretend what is to be you. Therefore, I know what you're going to do. I mean, you might not do that because you might hate your keys, so you don't want to look for them. Right? There's like certain probability of that. But then I would guess, why would that be? So that's theory of mind. I can pretend that I'm you and I can think what you would do.
Okay.
So imagine that the only way we can do the language is if I understand you and therefore understand the whole world. So if the language model can do language good enough, then it learns basically what it has a world model. It learns what it is, what the world is, and how to. So then it can grow. The same way human. It cannot modify itself, etc. But it can write new code to modify itself and etc.
You're also asking just about the first order effects. So can ChatGPT or Gemini or Anthropic, can they directly help building the next stage?
Yeah.
But there are massive second order effects. So imagine if it evolves to the point where it replaces a large number of jobs, then what you have is a large number of talented, capable people freed up from those jobs to work on the next iteration of technology.
Or starving, one or the other.
Unlikely, because there are reasons why humans tend not to starve, at least not in the long run. Maybe one generation will starve, but the next generation will not. They will find a way. That could be violence, but they will find a way not to starve.
Survival.
Yeah, exactly. Yeah. They have a strong survival drive, right? So the third order effects here are that you will have a large number of talented, ambitious people trying to find the next thing that makes them productive and through which they can compete in the world for resources, which is what we've been doing for a couple 100,000 years. So that will lead to advancements in all fields, or in the fields that are attractive, let's say, for the next iteration. And this field is attractive for now. So you could theorize that a large number of talented, ambitious people will start pouring into it because they were displaced by the fact that, well, I mean, the machine is already writing my code. I better start doing something else. And I let the machine write my code, but I'm going to start thinking about how to make a better machine, faster machine, bigger machine, etc., or a machine that can solve some other problems, right, down to fundamental physics, etc. We've had examples of this, right? So you have the machine that helps with fusion, with tokamak predictions. You have the machine that does the protein folding, right? So you have advancements. Now, very recently, there was an improvement to an algorithm for matrix multiplication, the 4x4 matrix, which yields about 5% improvement on 4x4 matrix multiplication. But if you do larger matrices and this algorithm scales up to them, then you get an even better speed up. So because
this alone
is huge.
Has paid for itself in Google money. So this Google, the AlphaEvolve did it, and then it saved 1% pretty much of Google's total compute.
Wow!
Which if you just put that in money and how much they spent on training so far, I think you can make an argument that it paid for itself.
Wow!
And this gain you will have forever, for as long as we keep that algorithm. The knowledge about that algorithm alive, right? Which is, it has happened that we forgot things in the past. So if you're thinking about these effects, then you can clearly see a path where these machines will accelerate, they will grow, will become better to the extent that it is physically possible. If there is some kind of law of nature that prevents you from advancing past a certain thing, like we have with faster than light travel, for example, well, we believe that it is impossible to travel faster than light. Okay, that's a barrier. We cannot cross that barrier. And that does have a lot of consequence here on Earth, right? So, for example, communication from one continent to another, it has to obey these rules. But otherwise, there is no rule that says that we cannot make stupidly complex machines to build other machines for us, to drive robots to do farming for us. There's no physical law that prevents us from completely automating something like farming.
Yeah.
It's really down to resources. It's really down to, if you want to go there, it's down to money, but it's not, right? Money cannot buy you a very, very large body of engineers, software developers, product people who are motivated to create the structures, the companies, the regulations, etc., that are needed for us to fully automate agriculture, for example.
Let me give you a counter argument to that, because the decay of thinking, the atrophy of thinking is happening. Like, for example, policymakers, they use GPT to generate policies, okay? And then the people that have to apply the policies, or the people that has to adhere to the policy, let's say a new tax policy, whatever, they also use GPT to parse the policy. Okay?
Yeah.
So then what we have is, first of all, explosion in bureaucratic complexity, right? Because new, more complicated laws are happening. And you need more models just to deal with that part. It has nothing to do with like the technology or like getting better, etc. And at the same time, humans in this process are actually getting worse. Like in the same way when you do this vibe coding. So first of all, Andrei Karpathy introduced vibe coding like, I don't know, 2 months ago or something. And he's possibly, for me, he's one of the 7 kings of deep learning. Like he's the emperor and one of the emperors. And when he does it, he's like at the very top of his field, okay? So he has seen and he can see further than most people can see.
Yeah.
So when he does that, it's very different when I do it, okay? So I have so much to grow, to learn, and doing it denies my learning.
Does it?
Yes.
Okay.
Because it actually, what it does is it spits out a bunch of code, and then you at some point you get tired. Like you get tired of reading. You're just like, okay, is that going to work? I try it. I don't even accept. I try it. It doesn't work. Oh, it doesn't work. Okay, well, so that it stops you from thinking. It basically completely atrophies your thinking.
Yeah.
So you can completely have the other effect, which is humans just get worse. They just stop progressing. Yeah. That's not the same with any other. With farming, for example, you can say, okay, machinery changed farming. That's true. But the farmers are hundreds of times better at understanding farming.
Yeah, but there are hundreds of times fewer.
I know. But my point is they are better at...
but we can reduce them to 0.
No. So my point is, let's say blacksmiths, or we can reduce anything to 0, right? But the point is the modern blacksmiths understand material science, and the tooling that they had on the way make them better at understanding the field.
Astronomically better. Astronomically better. It's incredible.
But what this does to us, it's stopping us from progressing.
No, the current blacksmiths hold PhDs.
Yes, I know. But what I'm saying, the GPT for engineering, for software development, stops us from progressing. Okay.
But does it? Because if I am coming out of university, for example, I now have a tool that I can use for learning significantly.
But you don't.
It would be in a different workflow than what you're describing, because I fully agree with you. If I'm trying to achieve something and have a tool that helps me, and I'm trying to interpret, and I do that continuously, and it's just continuously wrong, I will just trial and error until I get what I'm looking for. Indeed, and therefore I have not learned what I'm trying to execute.
It's an incentive issue because you have the tool. You have no incentive to go and learn the fundamentals of the things that tool does for you.
Yeah.
And your argument is that this leads to the atrophy of intelligence. I never thought about describing politicians as atrophy of it. That should be a meme. That should be a meme.
But you say you can use it for learning, but you won't.
Why not?
Because it's so easy to not use it for learning. It's so ridiculously, and then it's also
it's like a deal with the devil.
It's like adding documentaries to my watch list on streaming platforms.
Yeah,
I mean, we know. We've seen the statistics. We know.
Fair enough.
You don't watch them. You don't watch them. And yeah, but this feature is here. We have it. That's it.
Well, that's why I think it's very important for, if you want, I mean, that's why people listen to podcasts and say, if you want to just get better, you have to use it differently. I'm not saying I use it amazingly, etc. But if you are not Andrei Karpathy, just don't vibe code. That's what I'm saying. And I'm saying, use it use it as not to interrupt your thinking. Use it separately. Don't use it in your IDE. Use it as a separate thing. Say like, okay, just help me to think about this. And then you, of course, because you're doing the thinking from the tokens.
Yeah.
So, like again, if you have, I'm not going to read 300-page documentation of ST7796S so that I can make a driver, because I have to look at the SPI timings. And I just want, like, just please make me a driver. Thank you. I don't want to upgrade my React Native. I don't even want to read the new things in the React Native. I don't want to, please do it. Okay, that's fine.
Yeah.
But that is very different than thinking about how I'm going to model the state machine. What belongs to what is actually activating the change, what messages are going to be passed in my system, and how am I going to design this? It's very different.
But for me, it completely depends on what your goal is in the end, right? Because if I want to be a better software engineer, then I can agree with you.
Yeah.
I use it and consciously use it in a way that makes you better at what you're doing, right? More effective at your craft. If I'm starting a business and I want to achieve outcome, I want to make as much money as I can, then this is like a means to an end. And I want to get there as fast as possible. So I can put my brain on zero, I can trial and error my way through, and then see if I can reach customers.
Yes, but my point is let's build a better future. Yeah. And that's a super short term thing.
A better future is it codes for me and I go surfing.
Yeah.
That's a better future.
Personally.
A better future for all of us. And to build actually the looking glass into complexity, it's so far from that. And we need to spend so much time engineering on it, and with its help, absolutely. But we also have to get better at engineering. We're just not where we can use it yet. That's what I'm saying. I'm not saying it's not going to get there. I'm not saying we're not going to get there. But if we just you have to understand, it's like a soma thing. I just want this to do everything. I don't want to do anything. Soon, I mean, that's what people say. The worst possible future is actually people just wear glasses and the AI tells them what to do.
Yeah.
Because the next one is like, well, why are you not going to let it to tell you what business you should make? Right? Oh, you do this business. Okay, now type this prompt. Why shouldn't it tell you the prompts that you should write?
People are already trying that.
I think it's really funny you're giving these examples, because the software development example is kind of like the blacksmith example today. So you could make something the old-fashioned way with a hammer and anvil and so on, but you can also order it online from Exometry and just give them a CAD model and it will come out perfectly.
Yeah.
And I think you're absolutely right that these tools can help you being a looking glass through complexity, but I think we're looking at the wrong kind of complexity, like the complexity of software. No, it's, as you said, trivial. Yeah. Like if we follow down this path, I think the smartest thing to ask these machines to do is diplomacy.
Yeah.
Right? So if you want a better future for all of us.
Well, but the next time is let them rule us, because the next thing, diplomacy, unless you act on it, so let them be our kings.
Well, I mean, they will be our government, in fact, because because we're still writing the prompt, so we are still the legislator.
No, because the people...
who's ruling here?
No. You say we're writing the prompt, but the next prompt is tell me the prompt that I should write.
Yes, sure, but that's fine. But we do that all the time.
Yes,
right?
but that's what I mean. It is writing the prompt, it's not you.
Yes, but that's also fine, as long as it's aligned, right? Because we're also doing this with politicians today. They're writing the prompt.
No, politicians are afraid they're going to be hanged.
But it's the same with the machine, right? It's going to be realigned. It's going to be retrained next year.
No.
Why not?
Because it can rule that it's not going to be...
We have constitutions for this. The politicians also cannot write every rule.
Who is interpreting the constitution?
I mean, it's turtles all the way down. We know that. But at some point, if things go south, we do stop. And that's what you call a revolution. And that's where you unplug it and plug it back again.
I'm just saying,
we still have that.
Like
you turn it off and on again.
Like I've been using it so long and so long. I literally had to take this week I'm off work just to code without it. Okay. I usually code 2 days. I always code without it, but I felt like it's just not enough. I just felt like I need just to go back. I just need to go back to thinking, to think about what I find complicated and just try to make something in a different way.
But you really enjoy it as well, right? The thinking act of it and then producing whatever you're trying to achieve.
Yes, because the purpose of me producing a thing is for me to just improve.
Yeah.
And so that's what I look at. And then regardless if it's in some enterprise code, or I can look at the screen for like hours and then just say, is that imagine that's the last piece of code that you're going to write. Is that how you want to be? And of course, at some point you're like, well, I still have to do other things, so that's okay.
Yeah.
But you still have to at least have some way of like, what is happening with me while I'm doing this?
Yeah.
You have to have some self-awareness about. And I just felt like this I was so many. I actually wrote a blog post recently about like so many accept. Oh, it's not working. Oh, what are you doing? No, that's wrong. Just do it the other way. Then it does something. And accept, reject, accept. And then after the day, I look back at the day and I'm like, nothing happened with me. I just lost my day.
What we're seeing now, I think you're very unique in that you truly enjoy like the creation of it. And you've done this for many years, especially in the last, I would say 5 years. And this is just an arbitrary number. People are coming into this field, not necessarily for the love of
That's
it,
true.
right? They're coming from someone from a lower income base. They see that all this knowledge is out there, shared in the open. The barrier of entry was very achievable, right? Teach yourself to be productive. Teach yourself to execute. Means to an end. And now we're seeing the great culling. Because the people that really came into that for this, they will stop learning because the means to an end now got a lot easier. Absolutely. And companies are seeing this and they don't need that. They need the deeper knowledge, the layer that goes underneath that truly understands. And also, to a certain degree, if you truly understand, you have to really enjoy what you're doing. You can't just use it willy-nilly to achieve a means end because everyone can do that nowadays. Yeah. So then this is the culling, basically. And I'm wondering what you're saying, Raresh, where all of these people now come out to the market. It's not just tech, but it's also everything around tech. Course. Tech ops, for example, sales ops, anything like that. It's very hard to get a job because things are being automated. People are being more productive. So then what are those people going to do?
Yeah, I mean, they're going to keep on being humans. They're going to adapt. Many of them are going to adapt. Some of those who adapt are going to be successful. And some of those who are successful are going to be extremely successful. And in fact, if you look at the history of economic downturns, of market crashes and so on, after the dot-com bubble, you had the resurgence of Google and then later on the social media and so on. These are startups that came out of people who were laid off in the dot-com bubble. Yeah. So humans are going to do the human thing. They're going to adapt and fight for it and so on. Maybe a bigger problem of this is the cheapening of the work product. So if you're thinking about crafts, you could think about people who used to paint versus putting up wallpaper. You could look at wallpaper as being an extremely efficient way to paint your walls, or you could look at it as a cheapening of the craft. And depending on your position and the way that you position yourself towards the craft and the way that you value the craft. For example, Borislav and I value software engineering quite highly because we've been doing this for too long. And yes, I like to be productive, and I'm sure Borislav likes the driver to write itself. But also there's a certain beauty to go into the code and to really get it, right? To really understand, okay, this is assembly and this is what it does with the chip. And there are people out there who bend it, who go beyond the spec of the chip and go like, could I maybe up the frequency just a little bit? But what happens if, right? And sure, when you're one of those, then you look at this and you're like, oh, this is a nightmare. They're completely ruining everything I've been thinking is amazing. There's no such thing as amazing. There's no such thing. Like the blacksmithing is only extremely valuable in the eyes of people who appreciate blacksmithing. And if anything, today, it's much easier to be a blacksmith than at any time in human history. Because today, you could be a real estate agent, and then on the weekend, you can blacksmith all you want. And you know for sure you have a roof over your head and you have, right? So this is kind of the thing. But yes, people are going to transition from certain fields to other fields, but there's always going to be human activity, as long as nothing tragic happens.
Yeah, First of all, of course I enjoy coding, etc. But I do enjoy more like just growing. I enjoy more, and
but you equate those. Those are very close
exactly
to each other.
That's my point.
No, because I just go
those.
through. I go through all experience, right? It's not just through code.
Yeah.
But it's the way I do things. When I also do leatherworking and I also do metalworking and I just everything I do for me is the same. There is no difference in coding or in leatherworking. There is no difference. You just what kind of, or when you cook, it doesn't matter.
Yeah.
What kind of attention, how much attention you pay in the thing that you do and how you reflect on it. Right? So a lot of times I hate the thing that I have to code. I just have to do something. I don't like it. I have to do it, etc. That happens actually most of the time. Right? And I'm not saying that. I'm saying we just need to get better. We're not there. We have been running in circles with technology, trying to like come with the next abstractions, and we still cannot manage. We barely manage like PID controllers kind of complexity, and we need to get better in order for humanity to advance, to solve its problems. We just need better engineering, and we are on a path to get to worse engineering. That's what I'm saying.
Yeah,
and that is the danger. It's not about like love of the craft or like the craft is going to change. It's not the career at all.
Yeah.
It's about what people are going to build the tomorrow. What kind of people and how much are they going to know?
Yeah.
And with the help of AI, obviously, right? And I don't even know what people's jobs are going to be, but we need to make sure that we are on the path and what education is going to be. Of course, most people actually, I think easily 50% of the developers actually cannot program. That's absolutely the case. I've interviewed maybe 700 people. Easily, more than half of them just cannot program whatsoever. And that's like after like 10 filters of CVs and etc. And that's totally fine. They try to get better. They studied.
Yeah.
I mean, in many schools, you start studying programming at 12, and then you memorize a bunch of stuff, and you kind of get by. And because we still don't know actually how to teach it, so you kind of like go through some tests, and in the end, you graduate.
You do your best,
you do your best, and then you get to a company, and a little bit of Stack Overflow, a little bit of this, a little bit. Now it's even easier to kind of like fake it. But in the end, you still don't know how to program. That's it. You just don't know. You don't know what it is, and you don't know what you're doing, and that's okay. You can make money, and you can provide. The reason you make money is because you provide value for somebody else that needs the thing that you're producing. That's okay. I don't. But my problem is with the other people that are actually going to build the thing that's going to help us to get into to solve carbon, and we need to get better. That's and we are not going to get better unless we try to get better.
I think I agree with you that we are on the path where we're going to do worse engineering. I think I agree with that. For me, then what is interesting is for the people that are on the path of, okay, we really need to solve human problems, and the means to an end here is engineering. If they can figure out a way where the tooling now enables them to find that layer of depth, right? Because the knowledge gap should be smaller, I feel like, with the tooling that is out there. So now it's a means of, how do I use this tool set that is there?
I mean,
we're definitely going to go quantity over quality, because I can do a lot with very little with the tool set that's available nowadays, much more so than 3 years ago. But indeed, we do need quality, always.
Well, you can say this like when you go to a grocery store and you have like a healthy thing and a fat and sugar on the other hand. Most people, regardless, you have to have a lot of discipline to actually pick the right thing. So this is like
that might be a cultural thing that's changing. I do see a lot of people putting more attention into
Yes. So they have to put the same into what they're doing.
Fair.
With engineering. That's what I'm saying. And just be critical of what you're actually doing and are you actually learning? Because in order for you to build the next thing, you need to learn. That's it. And it's not, it can help you and just use it properly.
We might not be there yet, but indeed, if I look at healthy options, what I put in my body, I'm being a lot more health conscious than I used to be years ago. And I see my friends and family are trending towards that same thing. It's not the same with the mind.
Yes.
People are not there with the mind yet. The mind is, you go YouTube, you go TikTok, you zone out for hours on end, and you do that the next day.
Yeah.
And that's like junk food for the brain. We're not there yet.
That's what I mean.
Yeah.
And so now it's so easy for you can ask other people how often when Copilot slows down, right? How often they're like, I just don't know what to type.
Yeah.
And then just observe that and think about what is actually happening.
This is also the absence of the zone. If you use Copilot for 20 minutes straight, you're not in the zone.
No.
You are just tabbing, mindlessly tabbing. And then, of course, now, now I have to write code. Well, what was I doing? Oh, maybe let me go get an ice cream.
Let's wait a bit.
Let me do something else. Maybe Copilot is going to be back online in 20 minutes and I don't have to do this.
People try and multitask, like do as many things while they're idle, basically.
Yeah.
And you can never get into flow.
Yeah. We will need to change our patterns for sure. But the thing is that these tools, they're gonna advance.
Of course.
So it's kind of a race because the tool is gonna end up being better and better. So you don't have to stop doing tabbing anymore. And I think the tool is gonna become a new abstraction layer where you program the tool to program the software that you wanna run. And then what you think about when you're thinking, I'm doing software development, you're going to think about different things. So people have not been thinking about CPU registers since the 90s, roughly.
Most people.
The vast majority.
I've never had to.
Yes, but that's the thing. The vast majority of programmers before the 90s had to. And then the vast majority after the 90s didn't have to. There's always, of course, a small delta, but right, and now since the 90s, we've been thinking about all sorts of things, right, and software patterns, etc. And now we're getting to a point where we need to think about other things, higher level things. They're no longer abstractions that you can directly link to one another as we did before. In a sense, this is emergent behavior. We managed to program computers to a point where because in the end, the language, the models, the neural nets, they're all working on Turing machines. So these are programmed in the classical way, right? And we've discussed this before, right? So you're going from classical programming to programming neural nets. And neural nets, in a sense, are an emergent property of Turing machines, but they're not per se a Turing machine. They're a probabilistic kind of machine.
I mean, if you think about it as it's a search space, you know, like a search from all the possible paths and the way it finds things. It's very different than a Turing machine, for sure, but it still can be deterministic.
It's deterministic. Yeah, of course.
But it is definitely a very different. It's really Whereas the thing is, you know, when Turing made a Turing machine, why everybody understood the Turing machine, and church numerals were not. It took us. It was still like if somebody explains to you the church numerals now, you'll be like, well, and selection. If they explain to you selection and the way if works in lambda calculus, you'll be like. I don't, but if you know the way if works in the Turing machine, every single person can be explained the if in the Turing machine. So I think you can say the same about this new machine. Yeah. Right? So it's just strange.
Different paradigm.
It's just strange.
Different paradigms. So then we need to start learning its tools. Just like, you know, pre-90s, you would directly shift images into the video buffer, right? You'd have, While post-90s, you would start calling DirectX, open that API, and then cry a bit and try to
but it's also because it's like pipelines and buffers, because we keep adding...
Yeah, but it's a different paradigm. The engineers learned post that moment drastically changed from what they used to learn, what they had to learn pre that moment. So I think the vast majority of engineers are going to make the switch over post-vibe coding, and they will still be engineers because fundamentally an engineer is someone who makes something work in a productive way, right? There is no fundamental definition of it. Like a civil engineer. Of course, on Reddit, people argue this a lot. A civil engineer is not the same as a software engineer. Okay?
Alan Kay has software engineering is an oxymoron.
Yeah.
So,
but they are. But they are in society's eyes. They are engineers. They take some kind of human desire, and they turn it into an artificial product of the human mind through their own skill, experience, and knowledge. Yeah, and whether that involves or not the understanding of registers, it doesn't matter.
No, yeah, I don't.
It doesn't matter.
Absolutely the case, right. But I can give
just like civil engineers are not metallurgists.
So an example that would be using the language model without understanding tokens. Okay, that's just an example.
Yeah.
So I'm not saying that you shouldn't think about registers. I'm saying it's helpful for you to understand registers and, for example, at least maybe word lines
helpful,
and cache
yes.
lines.
Necessity.
You keep like moving further away, but that's just because of our inability. But if you understand it, does it make you better or worse? Let me ask you like this, okay? If you understand it, does it make you better or worse? Like, for example, there is Vertasio made this like video recently about this like building in Chicago, maybe, that was about to collapse because they made a mistake of like welds, bolts instead of welds. And the person that found the mistake, right, they just thought something was wrong, but then the architect, because he understands metal, right? So the fact that he understands just makes him better at his job. It doesn't mean that he has to think about it all the time. He thinks about like higher level of like, okay, this kind of works, the patterns and
yeah, but that is his job. Like that person's job was to understand metal. You understand
yes.
that?
No, yes, I know, but
there's a higher level person. There's an architect, and then above the architect, there's the customer that bought the building, and so. So at these different levels of the, let's say, the value chain of building skyscrapers, different people's jobs are very different, and they don't necessarily need to understand much about the level below.
Yeah, that's true. No, I understand. But my point is, if the person above understands, they don't need to, but if they do, are they going to be better?
Yeah,
yes, but that's what I mean.
You need to
at their job, not necessarily. No, at their job, at their job, not necessarily. Better as in terms of human growth, and I mean, of course, knowledge and experience and good judgment is always better, right? Do you want to know everything about everything? Well, I bet you do, but it's not really a necessity for your job because the job has limits. You're working inside of a box.
No.
Yeah.
Everything is connected. There's no.
If I'm building a skyscraper, I have a budget.
Yes, but you have to understand weather and climate.
Maybe yes.
Well, I think so. For me, this is always to a certain degree you need to understand things, and then depending on what your use case is, that's going to define the depth that you need to understand it. If I'm a project manager and I'm just orchestrating the whole thing, I need to align people. That's my role and responsibility, basically. Experts on how to build this skyscraper. And I would love to know enough to not be bullshittable, basically.
Exactly.
But always
that's the level of depth.
I think Borislav's point is that you could always know more about those experts' jobs.
I would love to.
And if you did, then you could do a better job overall.
But then I would be able to do their job, and I don't have
Possibly
to.
Yes.
Yeah.
Possibly yes. But even if so his hypothesis is if you knew more about their job, you could do a better job overall.
Yes.
And I don't think that there's an equivalence sign between those things because if we have 6 experts, so we're a team, we have 6 experts, right? Let's say I'm the program manager, right, of the team. I don't know anything about their job, okay? That's scenario 1. Scenario 2 is I also know their jobs. Well, the total amount of skill in the room is the same. You could say there's more capacity, but ultimately the total amount of skill in the room is the same. So the outcome should be the same.
It depends, because if you're going to collaborate, this is also where, because people grow from a certain role to all of a sudden the role of an overseer, they start to micromanage because they are an expert in that role and because they knew that role. Or they start to
so the outcome is going to be worse.
Exactly. It could also be worse in the end because you're now an extra expert. In a room full of seniors, nothing might be done, and you're just an extra person there.
First of all, because people are incredibly multidimensional, and there's like some distribution to the skill. So when you say an expert, I mean, in a group of people, somebody is below average. That's by definition what an average means, in some dimension. Right? So how are you going to put the right person in the right task?
You cannot.
Well, but if you understand their job and you see their code and you say like wait, because you're still constrained by time.
I can understand their job, but I don't have to be able to be as effective as them.
No. I'm not saying you should be effective. I'm not saying that but you should be able to understand deep enough, which means you have to be able to. What if I mean, you split the thing into like 10 tasks, right? And you have to just assign them. So you understand enough programming that you've seen the code of each of those people, and you know very well which person will do what, because not everybody is good exactly the same of everything, right? So therefore, unless you start micromanaging, which is obviously a mistake.
Yeah.
But just the ability to put the right person at the right place requires you to understand what they're doing. And so, of course, you can be a yes. So therefore, I mean, that's like counter argument to RLHS, which is then the output will be better because people are going to do the optimal thing.
Yeah.
So I don't know how many. I've definitely put the wrong people in the wrong place, and then when you just put them in the other place, it's just 10 times better, easily.
Yeah.
The same person 1 month later, not like so.
Yeah.
That's because I know how to read their code. But if I didn't, then I would just think, oh, this person is underperforming.
Or would you say people that don't have that capability? Because this skill, you're, I think, putting in the effort to not let this kind of grasp of programming atrophy. But a lot of managers have let it atrophy, right? They would have said, okay, I've been managing for 10 years and I do some hobby projects, but that's it. And now the abstraction layers have grown to such a level where it's just they're outdated.
Yeah.
And their ability is still a lot of people management, right? In hiring, do I want to work with these people? Do they mesh well? Do they add a little bit of diversity? Or do we need the same people to make decisions faster and execute?
Yeah. I mean, that's it's a very hot topic, I think. I don't know, people are like, a lot of people say you shouldn't know the craft. If you're a manager, you're a manager. I think that's absolute nonsense.
Yeah.
Like absolute nonsense. Raris is going to disagree with me heavily on that.
Yeah.
But I think managers should absolutely code and should sit with at least a day with their coders and just code on the thing. How would you know what is broken? Because you get like broken telephone stuff. Somebody tells you, oh, we're not delivering this. Why are you not delivering this?
Yeah.
Just go and code with the person and see what is happening. For example, in booking, we had this thing where when you make a change, so booking is a Perl shop, and it's really hard to debug, right? So you have to print the bug, basically. And then the web page. And so you print the bug, but the page takes 2 minutes to start. Okay, so when you restart, it just takes 2 minutes.
Horrible
So you
experience.
print, and then, I mean, it's a normal legacy code-based thing. Nothing, I don't think it's like amazing or horrible or anything. I'm just saying you need to wait 2 minutes every time you do an action, which means you have to go and get a coffee because it's like what you're doing. So if you are a manager of those people and then you sit with them for 10 seconds, like just code one thing, one simple thing, you'll be like, this is unbearable. We have to fix this immediately.
Yeah.
So while you're on the top, you just look at these numbers and you're like, well, the productivity, we release that many features. Well, that doesn't tell you anything about the experience, the developer experience, for example, at minimum.
I agree with that, yeah.
So, or what they trigger with, or maybe somebody made a library that like the API is just broken. This is broken. And how do you know if something is broken unless you feel it, you know? Or you're omnipotent or omniscient. So you need to experience the thing. You can't be so far ahead that you're like, oh, we just draw these boxes and then they work. That's not the case.
I'm right there with you on this front.
But the people that say managers only manage, they say, well, you just need to know people. But knowing people is not enough.
No.
I think.
I think you're conflating managing people with managing the environment, and managing the company and managing the software stack and so on. So I think you've described 3 jobs there. So there is a person who needs to manage the people. We're talking approval of holidays, making sure there are no interpersonal conflicts, stuff like that. And those, they don't really need to know how to
imagine
code.
somebody pushes like shit code, okay?
That's okay. There is another person who manages the quality of the code.
Wait. But the quality of the code is a function. Let's say in booking, I always got exceptional reviews. Only once I got exceptional, what was it? Potential. It was potential,
Okay.
and so I had exceptional potential, but like medium
output.
And that was the month that my grandfather died. Okay? So because the person that approves the things is, you see, and they are related,
Yeah, but thank God that people can talk to one another, right? I mean, there are functional and dysfunctional organizations, and there are within them there are functional and dysfunctional cases, and so on. But the point is that you're trying to put in a lot of responsibility over one person. So one person cannot, in a large organization, especially like booking with a lot of internal complexity and also external, one person is not enough for a team. So you have to have multiple people.
Yes.
So I think that in the interest of being able to split those responsibilities, the manager should have reduced and deeper personal responsibilities over the people, right? And a new function should appear for responsibilities against the technology. We already have one for business, the product manager. I mean, we the industry, yeah. Right?
Collective.
We have the collective we have product manager that handles the responsibilities related to the business. And then the manager has, budgeting, peopleware, and you're trying to wrap them with the technical stuff, right? And I just disagree with that because there's a bit of a conflict of interest. Because they're wrapped up with business and with a budget, then trade-offs are now biased. If
they
we're
will
thinking, technical depth-related trade-offs,
yes.
For example, right? The typical example: every single engineer who's ever worked in an organization of more than 3 people knows that this is going to be a source of conflict. Like, when are we going to finally get to that thing that we all know we hate? Yeah. Well, when you're the person who's responsible for both the quality of the code and the budget of the team, then you're in a conflict of interest here now. You cannot make inside of your head a well-reasoned argument for either or.
Well, look, I'm not saying that we should have like a mini demigod in each team. I'm not saying that. I'm saying that the further you get away from the atoms of the company, which is what is being built, right? The further you have to experience it. Because the organization has like motives. The organism itself, an organization is a very complicated entity. It has some,
but where do you stop it?
No. So what I'm saying is, you can just keep everything and just go to the production line, basically. You don't have to go every day, but you go and then you experience what is actually happening here, and then you can at least confirm that what you think is happening is actually happening.
Okay, but where do you stop? At engineering manager level, senior engineering manager, director, CTO, CEO? Where do you stop? Because I can make this argument all the way to the board, all the way to the shareholders.
The shareholders should code a little. I think that
no. The shareholders should understand what the engineers are doing, because only then they are well informed.
I see what you mean. Yeah, that's
decision.
True. That's true. But I think, like, at least if you are managing a bunch of people, you should participate in what they're making. I think maybe I don't know if the CEO should go. As a CTO, I code more than I just code, but it's a super small company, right? So, but if it was a bigger company, I think I would still code at least. You don't have to code every day if you can't, right? You obviously have to do a lot of other things, but you can make time to shadow somebody or peer.
But you want to. What I'm asking about is what's necessary.
But I do think it's necessary.
You think it's necessary?
I think it's especially now when everybody, when the world is so complicated, everybody has different incentives. The organization has some incentives. Like, people want to get promoted, so there's like sabotage of projects in like companies like Facebook or etc., where it's so intense to have impact. It's so important, and especially with the layoffs now, there are all kinds of like incredibly broken incentives in the organization. So when somebody tells you something is wrong, it's like there's this video on YouTube. There is this. I mean, that's a little bit dark. There is this guy that was in Vietnam, and he came back, and he's like, we go out and then we lose 5 people. So we come back and we report, well, we killed 50, because we can't lose 5
without doing anything else.
Without killing 50. But we didn't even see where they killed us from.
Oh wow!
So it's like, the manager. You see what I mean?
Yeah.
So
you don't want to get, basically.
Yeah.
So you have to, when everything is so perverted in the organization, everybody has different, the product owner has one completely different instead. They have to ship the thing. The engineer is like, oh, I have to work on this like impactful thing. Is it impactful enough? The product owner is, I have to move teams because I need to get to this other thing. And in the end,
get
like,
promoted.
And to get promoted. So how would the manager of the manager know what's going on? When somebody said, like, okay, this thing is not working. Why is it not working? Well, just go in for a little bit and see what's going on. Just pair with them, code with them, and see what they're making. What is the actual problem? And then think about it. I'm not saying you should do it every day. I'm just saying if you can do it, you're just going to understand what the organization is doing better.
I mean, even if I didn't have any technical knowledge, I could still do that, right? Go to the people and just see what their day-to-day is. See what is that dysfunctional behavior.
Yes, but the problem is just when it's technically, like, let's say some other team made like a broken API.
You would have to have an interest to be able to take that information in, but I don't have to be super technical to do that.
Imagine that I tell you, like, management says, like, look, you have to integrate, you're doing something and then we want to release a product, but we have to integrate with, I don't know, Salesforce now. And then people start integrating with Salesforce, whatever. But then you go in and you see that the Salesforce API is not
horrible.
It's horrible. Yeah. And then you're like, why are we? This is actually going to hurt us very, very much. People are just going to say, of course we integrate because they make business sense. How do you know it's actually going to hurt you in the long term unless you just see what's going on?
That's fair. Yeah.
Will I in the future just ingest all of Slack into a model and then ask what are the incentive structures of this company?
I think also you're going to see what is actually people do. And that's
very
also
privacy sensitive.
Sergey Brin said
company property.
Yeah, fair.
Slack
but personal conversations also.
Slack chats.
Yeah.
They're on company time. You block them, 9 to 5. Anything that happened 9 to 5.
Not in Europe, probably.
Company chats, company emails, all of Confluence, etc.
Sergey Brin recently had an interview where he did that in Google. In the beginning of language models, he said, well, there was like, I just took all the chats and then said like, okay, split the tasks. And then he just said it as if he said it instead of the language model. And then he said, like, from this room, who is actually should be promoted? And then the language model picked up some girl that was a little bit quiet, but she did tremendous amounts of work, which wouldn't have been picked up. So, yes.
It's nice to hear that misogyny does not translate well into LLMs.
Right.
That is really encouraging.
Perfect. I think that's a perfect way to round it off. Thank you so much, guys. I really enjoyed this discussion, I must say. Thinking of the impact on society and kind of this identity crisis of software engineers, for me, it's always fun to have a conversation with. Just thank you so much for joining.
Thank you.
Thank you.
We'll round it off here. If you're still here, let us know in the comment section what you liked on this episode. It's the best way to support the show, and otherwise, we'll see you on the next one.